Congratulations on completing another course section. And as always, let's take a few minutes to review everything that we learned. So first up, we learned about JavaScript and the browser. In fact, JavaScript as a language originated in the web browser. It was explicitly created for the purposes of adding interactivity to web pages. Node followed a lot after that, more than a decade after JavaScript was first introduced in the mid-90s. So JavaScript has a very long history with the web browser. It was made for that environment. And so it makes sense that it has all of this functionality related to altering the user interface. So as we learned, JavaScript can add, remove, and update DOM nodes. And a node is just a unit representing some visual element on the web page. We have a node for an H1 element, and a node for an LI element, and a node for something like a piece of text that is housed between a parent node element like an H1. So a DOM node can be viewed as just a complex JavaScript object that has a visual display or representation when we render it on the screen in our browser. All right. So as we mentioned, there are DOM nodes for all kinds of things, basically all the pieces that allow us to create the web page. And it's important for us to kind of separate the visual representation, right, from the JavaScript representation. Because as we learned, we're so used to seeing that rendering on the screen that we forget that we can model what we see on the web page purely from a programmatic perspective, purely as a tree of nodes, each of which have children. So we learned about some of these methods that are available on the core document object that is built into the browser. And these methods help us do things like find certain nodes on the screen or create certain nodes. So for example, the getElementById method locates an element by its ID attribute, and it returns the DOM node for that element. It returns a JavaScript object representing that piece of the UI. As another example, we saw the querySelector method, and that locates an element by its element name. So we can use querySelector to find, for example, the first paragraph tag or the first list item tag. And we didn't even explore all of the available methods. There's a lot more available. The point is these methods prove that we can use JavaScript to manipulate and to query the visual interface. Another example here was the createElement method, and that allows us to create a JavaScript node object representing some kind of HTML element. Now, this is kind of tying into the idea we were just talking about in that creating that node object does not mean it becomes rendered onto the screen yet. It's just existing in that JavaScript object representation. In order to actually render it to the UI, we have to add it by, for example, appending it as a child of another element. So the key idea here is we can totally not have a visual interface in order to model the modern browser experience, the idea of HTML, the idea of parents nesting children all the way down. We don't actually need a visual interface, right? We're so used to having these two ideas coupled together, but they don't have to be. JavaScript as a programming language gives us the ability to represent this idea of hierarchical structure of nodes without actually needing to render it all on screen. The problem with a lot of these nodes is that they tend to be pretty bulky. They have a lot of complexity in them built up in the browser over time. And so what React said is we're going to follow the original naming pattern that document gives us, but we're going to create a new method called createElement. And it's going to give you not a full DOM node object with all of its complexity, but just something called a React element, which is just, again, a JavaScript object, but a much more lightweight one that represents something that will eventually be an HTML element in your browser. Of course, what React really does is it stacks those React elements together. It organizes them within its own virtual DOM, which, remember, is sort of like this sibling DOM that exists separately from the browser DOM that is purely in JavaScript. And because it doesn't have to worry about any visual rendering, React can much more quickly run through that virtual DOM and do things like replace elements with other elements, or swap elements, or delete elements. Then, when that virtual DOM is out of sync with the actual browser DOM, React figures out what those changes are, and then it updates the actual browser DOM in the most efficient manner to make sure that the virtual DOM and the browser DOM are out of sync. So it sort of performs the majority of the logic on the virtual DOM where things are faster, right? And that's what allows it to be pretty quick, much quicker than the manual addition of all these things one at a time to the real browser DOM. And then it uses that virtual DOM as the basis for actually making those eventual changes to the browser DOM. So there's no way of getting around it. At some point, you will need to create those elements on the browser DOM, but React is optimized to look for the most efficient way to do that in the least number of steps and modifications to the DOM, right? So as we saw, the createElement method accepts the following arguments. The first is a string representing the type of the eventual HTML element. So for example, we can give it a string of h1 for an h1 element, or a p, or an a, or an li, totally valid. Then the second argument is an object of props, and those props will become attributes on the eventual HTML element when it is loaded into the real DOM. Again, why do we need an object? Because we don't technically have an HTML element. So we need a JavaScript construct to represent those eventual attributes, and there can be any number of them, right? So what's the most ideal thing to store a collection of key value pairs, like the attribute name and the attribute value? It's a plain JavaScript object. So that's exactly what we pass in, and that's exactly what it stores inside the element via the props property. Right. By the way, we talked about this a little bit earlier, but if you want to skip passing in any props or equivalently any attributes, you can either pass in an empty object as the second argument to createElement, or just the value null. All right. And finally, the third argument to the createElement method is going to be the children of that element that you're creating as the first argument, right? So you can have any number of children, and when you have more than one, you can either pass them in as sequential arguments to that createElement call. So in other words, they're going to be the third argument, fourth argument, fifth argument, all the way down to infinity. Or another approach is you can store those children within an array, and that array becomes the single third argument to the createElement method call. All right, and that of course brings us to JSX. We started the process of writing a lot of these createElement method calls manually so we could see how laborious and exhausting and verbose it was. So JSX is an abstraction over those createElement method calls. The word abstraction means it's trying to hide away some kind of complexity from us. It's trying to simplify an otherwise complex operation. So we could work entirely with all of React's features and never use JSX. We can just keep invoke and createElement and keep nesting children and keep nesting children and keep nesting React elements. But obviously that's not really scalable and pretty exhausting for us as developers. So JSX exists to make our developer experience more enjoyable. At the end of the day, JSX is still going to be transformed into createElement calls, which will be transformed into React elements, which will be transformed to eventual browser nodes. So there's a lot of kind of middle steps into the final goal of ending up with something on the screen that is ultimately HTML rendered by JavaScript, right? But the whole point is that it simplifies that process significantly. And as we know, whenever we use create React app, it includes Babel by default, so that JSX transpilation is available out of the box. We can just start using it and start using that JSX as if it's just regular HTML. Once again, it is not HTML. It is a JavaScript language extension. It looks like HTML, but it's just something fake. It's kind of an illusion, right? Because all that is just masking over createElement method calls under the hood. That's all that JSX does. It makes the process of writing this React code a lot easier. All right, that's all there's to cover in this lesson. Hope you had fun in this section, and I will see you in the next one.